So, as you just learned, we are looking for the values such that the probability of z being less than that value is some value, right? Um, we're looking for essentially the inverse of the standard normal curve. We're trying to find this guy such that this area over here is 0.02. Right, let's do this, right? So this area under here, we want it to be 0.02, and we're trying to find this value such that that is true, right? So, and this is the, this is an example in your chapter 7 examples. And they go through, and the book tells you and talks about how to do this using the table, right? So the table of standard normal probabilities. You guys are experts at Excel and SALT as well, I believe, at this point. And I wanted to take some time and talk about how we would do this in Excel or SALT. Right. So I give you the Excel command in the module section, right? So it's norm.inv, right? But here's a little bit of an example on how we're going to actually find those values, right? And what that is and what we're looking for. So here it is telling you that, it's about minus 2.05, and that's this value. All right, so we're going to go find the approximate, or sorry, that is the approximate using this table. We are going to go find the actual version from Excel. So what we're trying to find here, just as a reminder, we want the value here such that the probability that z is less than that value is 0.02. So as we mentioned, the formula here is norm.inv. So the first blank is the probability, right? So that is the probability that we're looking for less than at this point, which is 0.02, right? The probability of what we're looking for is 0.02. The mean, 0, standard deviation is 1. And we can see here that the probability that z is less than minus 2.0537 and a whole bunch of other numbers is 0.02, right? So you can see that we've got a slightly more precise answer than what we're able to find with the table. So we could do this for any possible value of the probability that we wanted, right? If we were looking for the probability that z is less than what is 0.5, the answer would be 0 because the normal is symmetric. You can kind of see also that because we can use the symmetry, we've also got the ability to find on the other side as well. So what we're going to do is we are going to, because similar to the table of standard normals, Excel also gives us the value to the left under the curve. We do need to find the probability that will be to the left of the curve, right? So if we're looking for the probability that z is greater than our number is 0.05, well, then that also means because the probability under the entire curve is 1, that means that the area under here to the left is 0.95, right? So we can do exactly as we did above, but use 0.95 to find the value over here. All right, so let me drag this back over here. So now we want the probability that z is greater than something is 0.95, which is also the probability that z is less than something. Oops, I jumped ahead of myself, right? The probability that z is greater than that value is 0.05, right? This guy here also means that the probability that z is less than that value is 0.95, right? Because we know that it has to be one or the other, and everything adds up to 1. So now in this case, we would say norm inverse norm.inv. The probability in this case, 0.95, mean of 0, standard deviation of 1. And we can find that the probability that z is less than 1.64485 is about 0.95. So the probability of being greater than 1.64 is 0.05. Right? So we can kind of do that in both directions, but you do have to make the translation, right? So if we want to find a z star such that the probability that z is greater than z star or z is less than minus z star is 0.04, what would that be? Right? Think about it a little bit from this perspective. We're looking for this value or this value under the curve. Well, conveniently, 0.02 twice is 0.04, right? So if we have another line here, then hey, we actually can figure out that it would be the same value. Right? We've got our minus. This is essentially making a point about how this symmetry works out for us. Right? And what should we do to find this value such that the probability is less than this guy? This one is making the point that you cannot just divide by 2, right? That's not how this math works, right? And we're looking for less than, so we want to find the value of the probability. Granted, the answer for this question is to use the table, but remember that we could just go in and do our norm INV here too, 0.01. And hey, look, it is very much not impossible to find this probability. We can find that this value is minus 2.32, right? And finally, we're going to go look at SALT and how we would do it over there. All right. I actually really like the way SALT does this as a learning tool here. We have our same setup, right? We're looking for the probability for a normal distribution with a 0 mean and standard deviation of 1. Probability that x is less than some value, right, is 0.02. So I can adjust this value however I'd like. I can make it 0.05, and it actually kind of changes it how it goes on this, right? So remember, we wanted the probability that x was greater. So we can swap to the right tail, right? So if we swap to the right tail, the probability that x is greater than something is equal to 0.05. Well, hey, this just gives us that number right away, right? And I can change it up and down, and this number changes accordingly. I can also change this, right? You can see how these values change as I'm changing these probabilities, right? We get to 0. Hey, the probability of being greater than 0 is 0.5. The probability of being less than 0 is 0.5. We've got all sorts of cool tools to be able to kind of figure out what's going on. You can do both tails. You can do between the tails. I guess in the middle, right? So the probability that x is greater than minus 0.3. And this one can actually change too, right? I can say, well, I want to be between 0.1 and 0.8. Well, that's 0.32%, right? This is super helpful. I can change the mean and the standard deviation. I can go and I can do all of these good things with the, oh, see, I didn't even know you could do that one. Just scooshes it out and pulls it back in for whatever reason. I don't know when you would use that, but hey, it's there if you need it, right? So these should be super useful for solving these types of problems, whether you use Excel or you use SALT, whichever one you're comfortable with. Just really kind of try and grok what's going on when we're asking these kind of questions with this inverse, right? Happy calculating.